Hey everyone, so in today's video we're going to be going over Charles' law. So as you can see, Charles' law, the equation for it is V1 over T1 is equal to V2 over T2. V1 and V2 being the initial and final volume, and then T1 and T2 being the initial and final temperature, both in Kelvin. Now it's really important that our temperature remain in Kelvin. So if we're given the temperature in degrees Celsius, we have to add 273 to it to convert it to Kelvin. So let's go over our first problem here. A gas occupies 2.5 liters at 300 Kelvin. What volume will it occupy at 350 Kelvin? So let's write out our equation. V1 over T1 is equal to V2 over T2. And we're looking for the volume it will occupy at 350 Kelvin. So we're looking for the final volume, which is V2. So V2 is equal to V1 times T2 over T1. And when we substitute our values in, V1 is 2.5, T2 is 350 Kelvin, and then T1 is 300 Kelvin. And when we plug this into a calculator, our final V2 value is going to be equal to 2.92 liters. Let's try another problem. A gas expands from 1.8 liters to 2.25 liters. If its initial temperature was 273 Kelvin, what's its final temperature? So once again, let's write out our equation. V1 over T1 is equal to V2 over T2. We want to isolate for T2 this time. So T2 is going to be equal to V2 times T1 all over V1, and then when we substitute our values in, this V2 is going to be 2.25, the initial temperature is going to be 273, and then the initial volume is going to be 1.8. That's going to leave our final temperature to 341.25 Kelvin, or 68.3 degrees if you subtract 273. So some real life application for this could be why this explains why a balloon shrinks when you put it in a freezer, or why, because as the temperature drops in the balloon, the volume, so does the volume of the gas, since there is a direct relationship between the two. I hope this video helped. Thank you.